Hi, welcome. In this video, we're going to do some practice with NPDAs and some context-free languages. So let's just review what an NPDA is. An NPDA is a 7-tuple. It has a finite set of states, an alphabet, a stack alphabet, the transition function, which includes lambda transitions because it's non-deterministic. It also includes the stack. So remember, on your transition with the stack, you can push onto the stack. You can pop off of the stack. You can ignore what's on the stack, or you can replace what's on the stack on the top. All right, so we are going to, Q0 is the initial state. You have an initial stack symbol. The stacks cannot be empty, and you have a set of final states. So let's get started. Whoa, look at this. This is a palindrome. So what is a palindrome? A palindrome is a string that is the same forward and backward. So in English language, I know one palindrome is race car, R-A-C-E-C-A-R. So R-A-C-E, that is a palindrome. Obviously, we're not going to do that because that would require a lot more transitions than this. We are just going to deal with an alphabet A, B. We have our stack alphabet, our initial stack symbol, and our A we're going to push on A every time we get an A. We're going to push a B every time we get a B. And then we have our 3 states. So this is not as complicated as it looks. It looks very complicated, but the thing is that you have to define a transition for each symbol for everything that's on the stack. So we have the 3 stack symbols, right? So if this is the transition. So if I'm in Q0 and the symbol in my string is an A and there's a Z on the top of the stack, I'm going to push an A. If I'm in Q0 and I encounter the symbol B and there's a Z at the top of the stack, basically that means this means if the A is the first symbol in my string, this is if a B is the first symbol in my string. So for every A I encounter, no matter what's on the stack, I push an A. I encounter an A, I push an A. I encounter a B, I push a B. I encounter a B, I push a B. So that's the first half of the string. Then you have to deal with the second half of the string. So if you want it to match, so if your string is A, B, 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 A, so you have the first half, and then we want to see if the second half is going to match. So the way that you do that is, here's our stack. We start with the stack symbol, right? So I have an A, and there's a Z at the top, so I'm going to push an A. Then I have a B, so I did this transition right here. Then I have a B, so I have to look. Okay, I have a B, and there's an A on top, so I'm going to push a B. And then I have another B, and there's a B on top, so I'm going to push a B. So if you notice, it seems like it's a lot, but you just have to take into consideration all of the stack symbols and all of the symbols of your alphabet and all of the transitions. So that's why it looks like it's so much. Then after I do that, this is the first half. Then I have my second half. But if you notice, I'm in Q0 while I'm pushing all these on there, my A's and my B's, and I get to my second half over here, and then I'm going to pop off. So I'm going to pop off if I get a B. If I have a B and there's a B on top, I pop that off. If I get a B and there's a B on top, I pop that off. And then if there's an A and there's an A on top, I pop that off. And now I'm back to my starting symbol, so I can take this transition right over here, and I know that this is a palindrome. But it's not that easy because we have to deal with even length string versus odd length string. So let's clean this up. And again, these are the transitions for the first half. This is the first half. You have each transition for each letter of the alphabet for each stack symbol. Then you have your second half, but we need to get from Q0 to Q1 but I'm just going over the first half, second half, and then you go to your final or accepting state if your first half matches your second half. But we also need to take into consideration even length string. That's pretty easy. With an even length string, you just take it a lambda transition, you don't consume any symbols, and you this totally should be a B here. I'm not sure what happened there, but that's okay. For some reason, I must have hit V. So this is leave the stack alone. So this, notice here, if there's a Z on top, this is push. So you're adding to the stack. If there's an A on top and the stack is the same, you're leaving the stack alone. Here, if there's an A on top and you have lambda, that means you're popping that A off. So here you're with an even length string, you're just going to make lambda transitions. You're going to do the first half, then take a lambda transition, and then do the second half. With an odd length string, you need to consume each whatever character it is. So again, you need to have all of the transitions defined, all 6 for an A with an A on top, a B with an A on top, an A with a B on top, a B with a B on top, an A with a Z on top, a B with a Z on top. So you're just defining all 6 transitions, and you need to consume the middle symbol. So if it was like B, 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 A, B, 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 this is odd length. It's not very exciting. I guess I could put an A here. A, B, 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 A, right? You need to consume that symbol so you can compare the first half against the second half, and then this is where you would consume that symbol. All right, so I'm going through this transition by transition. So let's go through this transition by transition. All right, so our first transition is if we're in Q0 and this is the top of the stack. There's a Z on the top of the stack, and an A is the first symbol in my alphabet. Then I'm going to push an A. Then if it's a B, I'm going to push a B. If there's an A and there's an A on top, I'm going to push an A. If it's an A and there's a B on top, I'm going to push an A. And if it's a B and there's a B on top, I push a B. And if it's a B and there's an A on top, I push a B. So this is just making sure that we have our first half is going to be, we're just keeping track of whether it's an A or a B. Imagine if you had to do this with the entire alphabet. All right, once I do that, then I can take a transition for my, I get to my second half. Okay, in order to get to my second half, I'm going to count, I'm going to pop off and match each time. And then if I match, I will go to the final state. But I need to make the transition from Q0 to Q1 on 2 different ways. One is on an even length string, which is I just make the lambda transition. If there's an A on top, I make a lambda transition if there's a B on top, and I make a lambda transition if there is a Z on top. And this is really bothering me. That should be a B. But I'm not going to re-record. I'm just going to fix it after. All right, that should be a B. For odd length string, I need to do all 6. If it's an A, I need to consume the A, but that's leave the stack alone. Consume the B, consume the A, consume the B, consume the A, consume the B. So now that I've explained it, hopefully this didn't look so crazy overwhelming. And we can do a few examples with the stack. But this has to be a B. All right, so let's do a few examples here. We have A, B, 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 A, B, and A, B, A, B, A, B, A, B, A, and B, A, B, and B. All right, let's just do a couple examples and see if our NPDA is working as expected. I guess we should do an even number. BAB, BAB. That's an even number. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is an odd number. Right. This is an even number. All right, so let's do this first one first. We're going to start here with our stack symbol there. So now we have our first A, and so we're going to push an A. Now we have a B, we're going to push a B. Now we have another B, we're going to push a B. And now we have reached the middle of our string, so we're going to take a lambda transition over here to Q1. So now when we get to Q1, if there's a B, there's a B here, so we're gonna pop that off. And now we have not defined what to do if we encounter an A. So this is if we were to encounter an A and there is a B on the top that is not defined. So that means that we're just going to be stuck in this state and we're not going to be able to move forward. So that means that this string is not in our language. All right, let's try the next string. Start over. Okay, we have an A and there's a Z, so we push an A. We have a B and there's an A, so we push a B. We have an A and there's a B. We have an A and there's a B. That's this right here. We have an A, there's a B on the top of the stack, so we're going to push an A. And we have a B and there is a A on the top of the stack, so we're going to push a B. And now we're going to consume this A right here. So we have a B on the top of the stack, and we're going to consume this this A right here. That's this transition right here. And then we're going to pop the B, pop the A, pop the B, pop the A, and this is in the language. So hopefully this you understand how this worked. And what if we just have a single B? Let's just see what happens with a single B. We have a Z. So we say here, we're going to push a B. Now we're going to take this lambda transition right here and leave the stack alone. And then we're going to get here and we will pop that B off. And so this should end up in the final state as well. All right, we have one more example here. This example is the number of A's equal the number of B's. So in this case, we have two states. We just have our initial state, and we're just going to, our stack alphabet is a little different here. All right, so when we encounter an A, we're going to push a plus. We encounter an A, we're going to push a plus. If we encounter an A and there's a minus on the top, then we're going to pop that minus off. If we encounter a B, we're going to push a minus. If we encounter a B, we're going to push a minus. And if we have a B and on the top of our stack is a plus, we're going to pop that off. So we're going to see if and then we just have the same transition into a final or accepting state. So we're going to see if this ends up with the same number of A's and the same number of B's. So we can do a couple examples. Again, I did animation here. So we have an A. So if we have an A, that means our first symbol is an A because that's our starting symbol. So we're going to push, that's pushing onto the stack the plus sign for A's. Then we have an A and there's a plus, so we're going to push on another plus sign. We have an A and there's a minus. We're not going to push anything. We're just going to pop that. We're going to pop that minus right off. If we have a B and it's the first symbol, we'll push the minus. Push minuses with B's. And if there's a plus, we'll pop it off. And then we can take our final transition to our final state. All right, so let's try a few strings for this language. B, A, B, A, B, and B, A, B, 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 A. All right, so I think we can do it with these three. Let's draw a stack over here. Starting symbol. All right, so here's our first transition. I'm in Q0. I encounter a B. If I encounter a B and that's this transition right here, then I'm going to push a minus. If I encounter an A and there's a minus there, I'm going to pop that minus off. If I encounter a B, I'm going to put a minus there. If I encounter an A, I'm going to pop that minus off. If my next symbol is an A and there's a Z, I'm going to put a plus there. And then I have a B, I'm going to pop that plus off. All right, so let's try the next one. First is a B, I put a minus there. There's an A, I'm going to pop that minus off. And then there's an A, I'm going to put a plus there. So here you can see this is a string with more A's than B's, so I will not be able to make it to the final state. So I will be stuck, so this one is not accepting in this language. Let's try this next one. So A, if there's, and I'll just go over to what the transitions are. This transition right here, the symbol is an A and there's a Z, I'm going to put a plus sign there. Now I have a B. I have a B and there's a plus sign there, so I'm going to pop that plus sign off. Now I have a B and there's a Z is there, so I'm going to put a minus. Now I have a B and there's a minus, so I'm going to push another minus. Now I have an A and there's a minus, so I'm going to pop that minus off. And now I have another A and there's a minus, so I'm going to pop that one off. So it has the same number of A's as B's, so that one will then be able to take this transition right here to the final or accepting state.